In this video, I'm going to do a walkthrough of the Paper 2 Foundation tier from June 2017. Okay, question 1. So we've got simplify. We've got 5p minus 3p plus p. So 5p minus 3p plus, and that's 1p. So if I've got 5p minus 3p, that's 2p, plus another p, that's 3p. Simplify m cubed plus m cubed. If you've got m cubed, if you've got 1m cubed, and you add on another m cubed, you've got 2m cubed. And finally, simplify. So we've got 10 plus 3c plus 5d minus 7c plus d. So we're going to add the like terms. So we've got plus 3c and minus 7c. And for d's, we've got plus 5d plus another d. That's a 1d. So what does that give us? We've got 10. For the c's, we've got 3 take away 7, which is negative 4. And for the d's, we've got 5 plus 1, which is 6. Question 2. Write 56.78 correct to one significant figure. So that's the first non-zero number, which is, well, there's that 5 there. And the number after it is 5 or above, so it will kick it up and it'll become a 6. But remember, that's in the tens column. That's in the tens, so it's not 6, it's 60. So it's like rounding to the nearest 10. So it's closer to 60 than it is to 50. Okay, question 3. A teacher asks the students in year 6 what type of transport they use to get to school. The dual bar chart shows some of the results. So we've got car, bus, walk, cycle and other. And boys are fully shaded and girls are the line shaded. So what's the most popular type of transport used by the boys? So that's the fully shaded. Which one's the highest? It's walking. So we can write walk or walking, doesn't matter which one. 7 girls walk to school. Show this information on the bar chart. So we've got to draw on 7 girls walking to school. So it should go up to 7 and along, and we can do some of the shading. As so. More of the students get to school by car than by bus. How many more? So how many get to school by car? Well, there's 5 and 9. So that means 5 plus 9 is 14. So car, 14. And what was the other one? Bus. So bus is 6 and 4. That makes 10. So bus is 10. So how many more? 4 more. 14 take away 10 is 4. The number of students in year 5 is the same as the number of students in year 6. What is the total number in years 5 and 6? So how many students are in year 6? So we need to add them up. So 5 and 9, that was 14. 4 and 6, that was 10. We've got 9 and 7 here. That makes 16. 4 and 1, here, which is 5, and 2 and 1 here, which is 3. Remember, we do have a calculator in this exam, so you could be doing all of these calculations even, on the calculator. So you don't have to do any of this in your head. And then what we're going to do now is add these numbers up. So if we had 14 plus 10 plus 16 plus 5 plus 3, or you could have done this in one go and done 5 plus 9 plus 6 plus 4 plus 9 plus 7 and so on. So what should we get there? We should get 48. So if you type that in the calculator, you should get 48. And it says the number of students, that's in year 6, that's in year 6. The number of students in year 5 is the same as in year 6. So there's also 48 in year 5. How many are there in total? Well, 48 plus 48, or 48 times 2, we should get 96. Question 4. Here are 4 fractions. Write these fractions in order of size. Start with the smallest fraction. So we need to compare the size of these fractions. So the way to do that is to make the denominators the same, make the bottom numbers the same for each fraction. So we can make each of the bottom numbers, each of the denominators, 30. And we're going to leave this one as it is. For 2/5, we're going to times top and bottom. 5 times what makes 30? That's 6. So we'll times top and bottom by 6. 2 times what makes 30? That's 15. So times top and bottom by 15. And what times 15 makes 30? That's 2. So we're going to make all of the denominators the same. So 2/5 is the same as 12 30ths. We've got 11 30ths. We've got 15 30ths. And we've got 14 30ths. So start with the smallest fraction. So this is the smallest fraction, 11 30ths, then 12 30ths, then 14 30ths, then 15 30ths. So we're just going to write them in order. So it's 11 30ths, 2/5, 7 15ths, and then 1/2. Okay, question 5. David sells CDs in a shop. The tally chart shows information about the number of CDs David sold on Monday, on Tuesday, and on Wednesday. Write down one thing wrong with the tally chart. So we're going to be looking for a mistake here. And you can see on Monday, there's 13 tallies, but only 12 written in the frequency. So they've added up Monday wrong. Monday should say 13. David drew a pictogram to show the information for Tuesday and Wednesday with this circle representing 3 CDs. Write down one thing wrong with the pictogram. So on Tuesday, we've got 3, 6, 9, 12, 15, which is wrong. And on Wednesday, we've got 3, 6, and then this must be 1.5. So 7.5, which is also wrong. So we could pick either of those. Wednesday is drawn as 7.5. CDs. This can't possibly be right. It should have been 8. Or you could say you can't have half, but it should be 8. Okay, question 6. There are 495 coins in a bottle. 1/3 of the coins are £1 coins. 124 of the coins are 50p coins. The rest are 20p coins. Work out the total value of the coins. So we're going to work out how many £1 coins we've got, how many 50p's we've got, how many 20p's we've got, and then we'll work out how much they're worth. So 1/3 of the coins are £1 coins. So you work out 1/3 by dividing by 3. So 495 over 3. And just type that into the calculator. And we'll get 165. So we've got 165 £1 coins. We know 50p's. We've got 124. And the rest are 20p's. So we know the total. Let's work out how many 20p's there are. So 495, take off 165, and take off 124. Again, type it into the calculator. And we should get 206. So now we know how many of each type of coin we've got. So let's work out how much they're worth. So for £1 coins, that should be pretty easy. £1, we've got £1 times 165, 165 pounds. 50p's, we've got 124 50p's, and well, we could either say 2 50p's make a pound and half it, or we could times it by 0.5. Either one of those, absolutely fine. I'm just going to half it. So that's £62. And for the 20p's, we've got 206 of the coins. And then we can either say 5 of those make a pound or times 0.2. Either one of those again. And we should get £41.20. So what's the total amount of money? £165, £62, and £41.20. So add them all up. And we should get £268.20p. Okay, the probability that a new fridge has a fault is 0.015. What is the probability that the new fridge does not have a fault? So this is testing whether we know that all probabilities have to add up to one whole. So the fridge has either got a fault or it's not got a fault. So these two things have to add up to one whole. So we're just going to do 1 minus 0.015. Type it into the calculator. And we should get 0.985. And there's our answer. Okay, question 8. Here is a list of numbers. From the numbers in the list, write down a square number. So for square numbers, we're looking for 1, 1 times 1 is 1, or 4 because 2 times 2 is 4, or 9 because 3 times 3 is 9, or 16 because 4 times 4 is 16, or 25 because 5 times 5 is 25. From the numbers on the list, write down the number that is a multiple of both 4 and 6. So a number in the 4 times table and in the 6 times table. So the 4 times table is 4, 8, 12, 16, 20, 24, 28. There's no point in going any higher. And the 6 times table, 6, 12, 18, 24, 30. So we're looking for a number in both of those times tables. So we've got 12 and 24. From the list, 24 is there, so we'll write down 24. Write down all of the prime numbers in the list. So a prime number is a number that only has 2 factors. It can only be divided by 1 and itself. So what should we do? Let's look at even numbers are all in the 2 times table. So we won't have any of them as prime numbers. The 3 times table includes 21 because it's 3 times 7, and 27 is 3 nines, and then we've got 23 and 29 left. Are they in any times tables apart from the ones and the selves? No, they're not. So they are prime numbers. So we're going to write down 23 and 29. Not to forget, 25 is 5 times 5, so that's not a prime number. Okay, question 9. Find the value of x. So we know all the angles around the point, all the angles in a circle, add up to 360 degrees. So it's all going to add up to 360 degrees. This square here means a right angle. It means 90 degrees. So this one is 90 degrees. So we've got all of these 3 make 360. So if you've got 2x and 3x and 90, that has to make 360. Because all these angles, all around the point, add up to 360 degrees. So we can take off this 90. So 360 take away 90. And also we can collect these together. It doesn't matter which one you do first. If you've got 2x and 3x, that means you've got 5x. So we'll collect them together. And we want to take this 90 off. So we're just going to look at what's left without the 90. So if we take 90 off, that leaves us with 5x equals 270. So if 5x is a 270, how do we find out what 1x is? We divide by 5. So x is 54 degrees. And you can, obviously we're typing that in the calculator. We're not doing that in our heads because we don't need to. Okay, question 10. Sua is going to buy 150 envelopes. Here is some information about the cost of envelopes in 2 shops. So we've got letters to send. So 25 envelopes costs £3.49. And Stationery World, so a pack of 10 envelopes is £2.10, and you buy 2 packs and get 1 for free. Okay, so we're going to buy the envelopes as cheaply as possible. Which shop should Sue buy the 150 envelopes from? So, if she's going to letters to send, we want to buy 150 envelopes. They're sold in 25s. So how many 25s make 150? That's 6. So she needs to buy 6 packs. So 6 packs of envelopes. So 6 times £3.49. Type it into the calculator. And we should get £20.94. So that's letters to send. Stationery world. Okay, so buy a pack of 10 is £2.10, and you buy 2 packs and get 1 for free. So if you buy 2 packs and get 1 for free, that'll be 30 envelopes. So you buy 2, you get 1 free, so you've got 30 envelopes, and you've paid for 2, so that's £4.20. So at Stationery World, 30 envelopes are £4.20. So we want 150. 150 over 30, that is 5. So we need to buy 5 lots of 30. So 5 times £4.20. And that is £21. So which is cheaper? Which should Sue go to? She should go to letters to send. Letters to send is cheaper by 6p. Okay, so we've got a graph, question 11. A graph we can change between inches and centimeters. So we've got a conversion graph. Change 74 centimeters into inches. So 74 centimeters. So 70 is here, 72, 74. Okay, 74 centimeters into inches. So let's read off what we've got. We've got 29. Okay, Daniel's height is 6 feet 3 inches and 1 foot is 12 inches. What is Daniel's height in centimeters? Okay, so let's work out his height in inches first, and then we'll change the inches into the centimeters. So 6 feet is, so if we've got 6 feet and each foot is 12 inches, 6 times 12, which is 72 inches. And so 6 feet 3 inches is 75 inches. Okay, so we've got to change 75 inches into centimeters. So let's go back to our graph. 75 inches into centimeters. Okay, well, 75 is not on here. We've got a few options. We can do 50 and 25, or 25 and times it by 3, or any combination to make 75. Let's go to 25. So we're going to change 25 inches. Okay, hopefully that's accurate. I've got 64 centimeters. So 25 inches is 64 centimeters. So I'm going to multiply this by 3. So 75 inches. So 64 times 3 is 192 centimeters. So I've got 192 centimeters. There's probably going to be a range of answers for this question. So something in the region of 192 should be acceptable. Okay, question 12. Find the value of the square root of 13.4 minus 1.5 all over 6.8 plus 0.06 squared. So the challenge here is to type it in the calculator exactly how it looks. So if you press the fraction button, so that's the button that looks like this first, and then we should be able to type it in exactly how it looks. Remember the bracket on the bottom, very important. So I've typed it in exactly how it appears in the question. So the whole of the top line is under the square root sign, and the whole of the bottom is in the bracket and then squared. Write down all the figures on your calculator display, and there are a lot on mine. I've got 0.07330, 359081. Question 13. Rotate shape A 90 degrees clockwise about the center O. So we would usually use tracing paper. I don't believe I've got any available on here. So I would draw the shape on the tracing paper, mark where I'm starting, and spin the tracing paper around 90 degrees until the arrow is facing that direction, 90 degrees clockwise. And I should end up with a shape that looks like this. So the same shape rotated 90 degrees clockwise about the center, holding the tracing paper on the origin and spinning it around 90 degrees. Okay, describe fully the single transformation that maps triangle B onto triangle C. So this is a reflection. And where is the mirror line? The mirror line is the y-axis. So in the y-axis. Question 14, factorize. So that means put into brackets. So we're going to put this into brackets. What is in both of the two terms? They're both in the 5 times table. So we're going to take 5 outside. 5 times what makes 5? Or 5 times 1 makes 5. 5 times what makes 10m? That will be 2m. Factorize fully. So this time 2 and 6 are both in the 2 times table. A squared and A have both got an A in them. B and B squared have both got a B in them. So 2 times what? Well, 2AB times what makes 2A squared B? That's just an A. 2AB times what makes 6AB squared? 2 times 3 makes 6. We've already got the A, and B times B makes B squared. So we can check these. If we expand them back out, we should get the question again. Question 15. Write 4.7 times 10 to the power of minus 1 as an ordinary number. So times 10 to the power of minus 1 means divide by 10 one time. So that's 0.47. Work out the value of 2.4. Actually, with the previous question, so 4.7 times 10 to the power of minus 1, we could just simply type that into the calculator. So type it into the calculator and it will tell you the answer. B. Work out the value of 2.4 times 10 to the power of 3 times 9.5 times 10 to the power of 5. So again, type it into the calculator and see what we get out. Okay, so we should be getting out, just from typing it into the calculator, 228, and then a lot of zeros. So I've got 0, 0, 0, 0, 0, 0, 0. So 228, 0, 0, 0, 0, 0, 0, 0. And we need to give our answer in standard form though. So this is not in standard form at the moment. Standard form is a number between 1 and 10. So in this case, it'll be 2.28. And then times 10, how many times? So if you're at 2.28, how many times have you got to multiply it by 10 to get this number? So 1 would be 22.8. 2 would be 228, and so on. So 3, 4, 5, 6, 7, 8, 9 times. So we need to 2.28 times 10, 9 times. And again, you can check this in the calculator just by typing it in. So if you type in 2.28 times 10 to the power of 9, you should get back to this. So you should go back to this number if you type this in the calculator. Okay, question 16. A, B, and C are 3 points on a map. So we've got A, B, and C marked on the page. 1 centimeter represents 100 meters. Point T is 250 meters from point A. So 250 meters, if 100 meters is 1 centimeter, that's going to be 2.5 centimeters. Point T is equidistant from B and C, so the same distance from B and C. On the map, show one of the possible positions for point T. So the first thing we need to do, well, we're going to measure 2.5 centimeters from A. So we're going to use the ruler. And we're going to go 2.5 centimeters from A. So 2.5 centimeters from A, which is there. Then we're going to take the compass. And we're going to draw a circle. So all of the points So now we've marked all of the points 2.5 centimeters, so 250 meters away from A. Okay, so that's this bit done. Point T is equidistant from B and C. So we're looking for the same distance away from B and C. So we're going to use the compass again. So we're going to, it doesn't matter how big it is, as long as it's more than halfway to C. So we're just going to draw a circle, and then we're going to keep it the same length and draw a circle from C. So what we've done there is we have found 2 points that are equidistant. So where the 2 circles cross, that will be equidistant. They'll be the same distance. So if we join those 2 points up, what we get is all of the points. So that's all of the points equal distance, equidistant from B and C. So we just extend the line, and that tells us everywhere that's the same distance from B and C. So on the map, show one of the possible positions for T. So there are 2 possible positions for T. They are, here's one. At the first point, the line crosses the circle, and here's another one. We only need to show one, so we'll mark it there. Okay, question 17. The table shows the probabilities that a biased dice will land on 2, 3, 4, 5, and 6. Neymar rolls the biased dice 200 times. Work out an estimate for the total number of times the dice will land on 1 or 3. So we need to work out the chance of landing on 1 first, and again we need to know that all the probabilities have to add up to 1 whole. So we just need to find what's missing. So if we add up what's here already, so use the calculator, so do 0.17 plus 0.18 plus 0.09 plus 0.15 plus 0.1, type it all into the calculator, and that will tell us we get 0.69. So what more do we need to make 1 whole? If we do 1 minus 0.69, we get 0.31, and that tells us the probability of a 1. So we want a 1 or a 3 though, a 1 or a 3. So that's 1 or 3, 0.31, 0.18, add them together, 0.49. So that's 1 or 3. And we're going to roll it 200 times. So 0.49 times 200, type it into the calculator, and we should get 98. So we would expect to get 98 1s or 3s. Okay, question 18. On Saturday, some adults and some children were in a theatre. The ratio of the number of adults to the number of children was 5:2. Each person had a seat in the circle or a seat in the stalls. 3/4 of the children had a seat in the stalls. 117 children had seats in the circle, and there are exactly 2,600 seats in the whole theatre. On this Saturday, were there people on more than 60% of the seats. So we're working out how many people are in the theatre. So we know, well, I think we should start with what we know. So 117 children had seats in the circle, and 3/4 of the children had seats in the stalls. So you can only sit in the circle or the stalls. So that means 1/4 of children are in the circle. So if 1/4 of children are in the circle and 117 children are in the circle, that means 117 is 1/4 of the children. So we can find out how many children there are by doing 117 times 4. So if 1/4 of the children is 117, all of the children is 117 times 4, which is 468. So there are 468 children. Okay, let's work out how many adults there are. So we're going back to this ratio now. So adults to children is 5:2, and we know there are 468 children. So if we've got 5 parts adult, 2 parts children, and these 2 parts are 468. We can find out what 1 part is by halving 468. So half 468 is 234. So 468 over 2 is 234. So we know each of these parts is 234. 234 each. 234. And there are 7 of them. 1, 2, 3, 4, 5, 6, 7 parts. So 234 times 7 will tell us how many people there are in total. And that is 1,638. So now we know how many people are in the theatre. And is it more than 60% of the seats? And there are 2,600 seats. So we're going to work out what percentage is full. So we have got 1,638 seats taken out of 2,600 in total. So this fraction of seats are taken, and to change the fraction to a percent, we'll times by 100. So let's just type it in the calculator. And that is 63%. So 63% of the seats are taken. So yes, it is more than 60. Yes, more than 60%. Question 19. The diagram shows a prism with a cross section in the shape of a trapezium. So we can see we've got a trapezium at the front of the shape. And we've got all the measurements drawn on. On the centimeter grid, draw the front elevation. So what it looks like if you're standing over here. And the side elevation, so what it looks like, that is not a person, if you're standing over here. So the front elevation Use a scale of 2 centimeters to 1 meter. So we're going to double all of these, aren't we? So this will be 4 centimeters and 4 centimeters and 1 centimeter. 2 centimeters, 1 centimeter, and we don't really need to know the diagonal, so I'll leave that one. So from the front, from standing over here, looking in this direction, what can you see? So it goes along, well, 4 centimeters, along 2 meters, along 4 centimeters. So along 4, up 4, along 4, up 4, and then up 1 on the right. So up 1, and then join up the diagonal. So that's what it looks like if you're standing looking at it from the front. So from this view, that's what you can see. From this side view, what can you see? So it goes along 2, so along 2, so up 1 to the first level, so I'll draw that on. Up 1 to the first level, and then up 4 the whole way, so up 4 to the back level. And it will look something like that. Question 20. Ollie drove 56 kilometers from Liverpool to Manchester. He then drove 61 kilometers from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometers per hour, and he took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive. So his total drive. So this is a speed, distance, time question. So speed, distance, time. And there's 2 parts to the journey. So we go from Liverpool to Manchester, and we go from Manchester to Sheffield. So from Liverpool to Manchester, it's 56 kilometers. 56 kilometers. And he went at 70 kilometers per hour. So this is distance. This is speed. We don't know the time for this part of the journey. From Manchester to Sheffield, 61 kilometers. That's distance. 75 minutes. Not hours, minutes, which is time, and so we don't know the speed for this part. We're going to work out the average speed for the whole journey, so we're going to do total journey, and we're going to work out speed, which is distance over time. So we need to know total distance, which we already know if we add these two up, over total time, which we don't already know. So we need to work out the time for this part of the journey, and then we can add it on to this time, and that will tell us the total time. So how do we work out time? If we cover over time, we get time is distance over speed. So distance over speed, 56 over 70. So 56 over 70, and that gives us 4/5. So 4/5 or 0.8, and that is in hours, which is useful. 4/5 of an hour. We will keep that, and we will change the other one into hours as well. So 4/5 of an hour for the first part of the journey. 75 minutes. So if you do 75 divided by 60, that's 5/4 or 1.25. So 75 over 60 is 5/4 or 1.25 hours, 1¼ hours. So for our total distance, we've got 56 and 61. For our total time, we've got 0.8 and 1.25. So kilometers per hour. These measurements are in kilometers. These measurements are in hours. So let's just type it in the calculator. 56 plus 61 on the top, and 0.8 plus 1.25 on the bottom. And I've got 57.1 to 3 significant figures, or 1 decimal place. And that's all we wanted. Okay, Janie drove from Barnsley to York. Janie's average speed from Barnsley to York was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Janie says the average speed from Barnsley to York can be found by working out the mean, so the mean average of 80 kilometers per hour and 60 kilometers per hour. If Janie is correct, what does this tell you about the two parts of the journey? So the time taken must be the same. So if both journeys were 1 hour, that would mean that the average speed was 70 kilometers per hour. Okay, question 21. So we've got two shapes here. We've got one shape in another shape. So we've got ABC, which is, oh no, ABC and EDC are straight lines, and EA and DB are parallel. So we're given some lengths. E to C is 8.1 centimeters the whole way. D to C is 5.4 centimeters. And D to B is 2.6 centimeters. Work out the length of A to E. So this is a similar shapes problem. We've got two triangles that are similar. One's an enlargement of the other one. So we've got a small triangle with 5.4 and 2.6 as its measurements. And we've got the larger triangle with 8.1 and, well, A to E, this is what we're working out. So we need to work out a scale factor. And we do that by saying, well, what do we multiply 5.4 by to get to 8.1? And we can do 8.1 divide 5.4 on the calculator, and that will tell us that it's 1.5. So to go from the small shape to the big shape, we multiply by 1.5. So to go from 2.6 to x, 2.6 times 1.5, type it in the calculator, and we should get 3.9. A to C is 6.15 centimeters. So A to C, 6.15 centimeters. So that's this one here, 6.15. work out the length of A to B. Okay, so we're working out this length. So the difference between the big shape and the small shape. So let's work out B to C first. So we'll work out B to C first. So to go from the big shape to the small shape, we divide by 1.5. So 6.15 divide 1.5 is 4.1. So this here is 4.1, which is this length. So to work out A to B, we're going to do 6.15 take away 4.1, which is, type it in the calculator, 2.05. Okay, question 22. Anil wants to invest 25,000 for 3 years in a bank. So we can go to personal bank, where compound interest 2% for each year, or the secure bank with compound interest 4.3% in the first year and then 0.9% in each extra year. So which bank shall we go to? So if we go to personal bank, we're going to have 25,000 times. Now, if we start with 100% and we add on 2%, that will give us 102%. So as a decimal, we've got 1.02. So to add on 2%, we can multiply by 1.02, and we're going to do it 3 times. So we're going to times by 1.02 3 times, and that will tell us how much we've got after 3 years. So £26,530 and 20 pence. Same with the secure bank. So we've got 25,000. Okay, we want to add on 4.3%. So that's 104.3% as a decimal, 1043 in the first year. Then we want to add on 0.9%. So that's 1.009. So that's 100.9% as a decimal, 100.9% as a decimal. If you don't know how to change a percent to a decimal, just divide by 100. And we're going to do that for 2 years. So we're going to type it into the calculator. 25,000 times 1.043 times 1.009 squared. And that gives us 26,546 pounds and 46 pence, rounding to 2 decimal places because it's money. So where have we got more money? We've got more money in the secure bank. So the secure bank. Okay, question 23. A number n is rounded to 2 decimal places. The result is 4.76. Using inequalities, write down the error interval for n. So if we've got 4.76, the one before it, to 2 decimal places, is 4.75. The one above it is 4.77. So the lower bound was 4.755, halfway in between, and the upper bound is 4.765. So we just need to get our inequality signs right. So it can be bigger or equal to 4.755, but it won't be equal to 4.765, because if it was 4.765, you would round it up. So we want the or equal sign on the lower bound, but not on the upper bound. And question 24. So we've got to solve a quadratic. We can do that by factorizing. So 2 brackets, x in both. So we're looking at what multiplies to make 24 and adds to make a 5. So we can have 1 times 24, 2 12s, 3 8s, or 4 6s. So which of those can we make a 5 out of? 3 and 8, and we want a plus 5, so we can have plus 8 and minus 3. So then what does x equal? Well, x equals, what makes this bracket 0? Minus 8. What makes this bracket 0? Positive 3. So x is equal to minus 8, or x equals positive 3. Question 25. Here are the first 6 terms of an arithmetic sequence. Find an expression in terms of n for the nth term of this sequence. So we're looking at a sequence. You should be able to spot it's going up in 5s. So it's going up in 5s each time. So it's a bit like the 5 times table. So the 5 times table is called 5n. So the 5 times table is 5n, and that's 5, 10, 15, 20, 25, 30. But the actual sequence isn't that. It's 2 less. It's 2 lower each time. So it's the 5 times table, take away 2. So this sequence is called the 5 times table, take away 2. 5n minus 2. Part B, the nth term of a different sequence is 3n squared. Nathan says the 4th term of this sequence is 144. Is Nathan right? Show how you get your answer. So n is 4. The 4th term means n is 4. So we're saying is 3n squared 144. So 3n squared is 3 times n squared. So 3 times 4 squared. And 3 times 4 squared is 48. So no, he's incorrect. What he's done is he's done 3 times 4 first and then squared it. So only the n is squared here. It's not 3n all squared. It's only the n is squared, so it's 3 times 4 squared. So it's 48, and Nathan is wrong.